Welcome back to the Deep Dive. It's that time again, where we take a stack of information, and this time it's a truly fascinating collection of source material, and we really dig deep.
Yeah, we try to find those essential nuggets of knowledge, right? The surprising connections, the things that genuinely broaden your perspective.
Exactly. And today's sources are, well, they're a captivating mix. You could think of it like opening some kind of intellectual treasure chest.
Filled with all sorts of disparate facts and really profound ideas sometimes. It spans everything from the hidden biological secrets of Arctic animals
Right.
all the way to the enduring ingenuity of ancient engineers, and then lands like squarely on the bleeding edge of how technology is reshaping our minds and, the very future of work.
And our mission, as always, is to cut through any noise, get right to what's truly interesting and important across these diverse areas for you, the listener.
We want to equip you with insights quickly but thoroughly too. Provide just enough detail to be memorable and maybe spark some further thought.
Definitely. So get ready, because we're going to uncover things like how a polar bear's fat could potentially lead to human medical breakthroughs. That's pretty amazing.
It really is. And reveal the essential, often overlooked roles of the microbes that are all around and, crucially, inside you.
Then we'll step back in time a bit, appreciate Roman tunnels that are still in use today. Can you believe that?
Incredible. And we'll look head on at how reading on screens is subtly, perhaps worryingly, changing your brain.
It's quite a journey across vastly different scales and time periods, but the connections, they're surprising, and the insights are definitely waiting.
Absolutely. Let's get into it.
Okay, let's unpack this then. We'll start with some unseen worlds, beginning in maybe the harshest visible environment we're covering today, the freezing Arctic.
Yeah, a perfect starting point to discuss adaptation. Real extreme adaptation. The source material immediately highlights the intense challenge polar bears face.
Living in an environment where temperatures can just plummet to a brutal -40 degrees C.
-40. Just imagine.
It's hard to even comprehend. And while, their dense fur is famous, the source points out another critical adaptation, this incredibly thick layer of fat.
Up to 11 centimeters deep right under their skin. That's a substantial amount of energy storage and insulation.
It absolutely is. And here, this is where it gets really interesting, right? It presents a significant paradox.
Yeah, because if a human being carried a comparable level of fat, they'd almost certainly be facing severe metabolic health crises.
Right, things like type 2 diabetes, atherosclerosis, heart disease, a whole host of complications linked to obesity.
Exactly. Yet the polar bear appears remarkably immune to these kinds of problems despite this massive layer of fat.
It just flies in the face of our understanding of fat and health in humans. How do they manage this? What's their secret?
Well, that was a fundamental question researchers set out to answer. The source references a pretty significant 2014 study led by Shuping Liu and his colleagues.
Okay.
And they really delved into the genetics behind this remarkable adaptation.
Okay, so they looked at the polar bear's DNA. How did that help explain this fat paradox?
They took a comparative genetic approach. So they sequenced the genome of the polar bear and then compared it extensively with that of its closest relative, the brown bear.
Ah, okay, because brown bears live in much less extreme environments.
Precisely. And by comparing the genetic differences that have become prominent since the two species, diverged relatively recently in evolutionary terms, they could pinpoint the genes that were under strong selective pressure, the ones likely crucial for the polar bear's survival up there in the Arctic.
And did they find one? Was there a specific gene they identified related to processing or dealing with all that fat?
Yes, they made a key discovery. They identified a specific gene called ApoB that appears to play a really crucial role.
ApoB. Huh. I feel like I've heard that gene mentioned in human health contexts before.
You probably have. It's highly relevant. The research found that the polar bear's version of the ApoB gene significantly reduces levels of low-density lipoproteins.
LDLs.
Which in human health conversations are commonly, referred to as bad cholesterol.
So wait, despite carrying all that fat, they have a genetic mechanism that actively helps keep their bad cholesterol low. That's incredible internal regulation.
It is. And the contrast with humans is absolutely striking. In humans, mutations in that very same ApoB gene are associated with an increased risk of heart disease.
Wow.
The polar bear exhibits a functional outcome from this gene that is, well, essentially the opposite of what we see when the gene is mutated in humans. It highlights a unique and really powerful evolutionary adaptation.
Wow. You mentioned earlier this has relevance to humans.
Yeah.
How does studying a polar bear's APA-B gene actually connect to our health?
Well, this makes polar bears a potentially invaluable study model for understanding human heart disease and metabolic disorders.
Hmm.
The specific insights gained from studying their unique APOB gene, how it's regulated, how it functions despite these extreme fat loads, could potentially unlock new pathways for medical research.
Or even lead to new treatments?
Potentially, yes. For cardiovascular conditions, metabolic syndromes in people, it's a really powerful illustration of how adaptation in seemingly distant species can offer profound lessons for human biology and medicine.
So these majestic animals, facing all the challenges of a rapidly changing climate, they might hold crucial keys to helping us address some of our most pressing health issues.
Yeah.
That adds a significant layer to the importance of their conservation, doesn't it? Beyond just ecological balance.
It really, really does. And the source, interestingly, goes beyond just the biological adaptations. It throws in some surprising non-biological details, too.
Oh.
Yeah, ones that give us a more, maybe nuanced picture of polar bears as complex beings.
Like what kind of details are we talking about?
Well, it mentions anecdotal evidence suggesting surprising levels of polar bear intelligence and problem-solving capabilities.
Really? Like what?
For instance, descriptions exist of bears exhibiting behaviors like hitting ice out of frustration when a hunting attempt fails.
Hitting ice when they're frustrated. Okay. That definitely paints a picture beyond just a, purely instinct-driven predator. It suggests a capacity for complex emotion or reaction.
Right. And then there are the truly unusual interspecies relationships documented in the source, like anecdotes about polar bears actually playing with sled dogs in certain Arctic communities.
Playing with dogs, that's astonishing, considering their natural predatory instincts towards potential prey.
It really challenges our assumptions, doesn't it? And the source brings up the particularly remarkable case of Ogodre, who's a hand-raised polar bear,
Okay.
and her owner, Mark Dumas. They reportedly share such a deep bond that they even swim together.
Swimming with a polar bear. Knowing that they are known to hunt humans in the wild, that relationship is utterly astonishing.
It is.
It just underscores that animal behavior, particularly in intelligent species,
Yeah.
can be far more complex and capable of surprising bonds than we might initially assume.
It does. It highlights that these are not just animals defined solely by their environment and, basic needs. They are intelligent, potentially emotional creatures capable of complex interactions, both within their species and, well, occasionally outside of it.
And circling back to the earlier point about their potential importance to human medicine,
Mm-hmm.
the source briefly touches upon the broader implication here. If climate change leads to their extinction, we wouldn't just lose a critical part of the Arctic ecosystem and a magnificent species.
No, we'd also lose the potential for these crucial medical insights and just the presence of this complex, intelligent creature on our planet.
It's a powerful and, frankly, sobering thought about what's at stake.
It certainly puts their conservation in a very different light. Okay, so we've taken a deep dive into the fascinating adaptations and surprising complexities of a large Arctic animal. Now,
Big shift.
big shift. Let's transition dramatically. From the visible, albeit remote, world of the polar bear, we're going to shrink our focus unimaginably down to the teeming, invisible life that is not only all around us, but profoundly within us.
The world of microbes.
Exactly, the world of
The
microbes.
microscopic architects of life. The source really emphasizes how truly ubiquitous microbes are, primarily bacteria, right?
Primarily bacteria, yes. They're found everywhere. In the soil, floating in the air, in every body of water, deep within rocks.
And inside us.
And mind-blowingly, within every single form of life we know of. From the simplest coral to, yes, the most complex human being.
And they've been here for an unfathomably long time. Ancient history indeed. The source even predicts they'll outlive humans.
They are the original and the persistent life forms on this planet. And for the vast majority of human history, their existence was completely unknown to us.
Right. Until
Antony van Leeuwenhoek. The source points to him, the Dutch lensmaker in the 1670s. He's credited with first glimpsing this hidden world.
he was obsessed with making incredibly powerful lenses, wasn't he? That was his thing.
He was. He grounds his own lenses, achieving magnifications of up to 270 times, which was revolutionary for the era.
Wow.
And when he turned his gaze onto a drop of seemingly ordinary lake water, he saw a world nobody had imagined, these tiny moving creatures he called animalcules.
Animalcules, great name. The groundbreaking moment, revealing this whole dimension of life previously invisible.
Absolutely. But it wasn't until much, much later that the connection between these animalcules and human health started to be made, often in a negative context.
Yeah, that's where Pasteur comes in, right?
That's where Louis Pasteur enters the picture nearly 2 centuries later. His pioneering work led to the development of germ theory.
Which changed everything.
It fundamentally changed medicine by linking some specific microbes to diseases. While incredibly important for public health, this theory, unfortunately, kind of solidified the largely negative image of bacteria as simply germs.
Yeah, pathogens to be avoided or eliminated. An image that persists widely even today.
It does, which, as the source material strongly argues, is a massively incomplete and, frankly, misleading view.
Okay.
It references Ed Young's work advocating for a concept he calls microbial tolerance.
Microbial tolerance. I like that. What does it mean?
Yes, and this is an absolutely crucial shift in perspective. The source highlights that while a relatively tiny fraction of bacterial species cause disease, fewer than 100 are mentioned in the source as notable human pathogens.
Okay, a tiny number, relatively speaking.
A tiny number. There are thousands upon thousands of species that are not only harmless but play absolutely vital, beneficial roles in maintaining our health.
So the simple friends or foes idea just doesn't cut it.
It's completely inadequate to describe our complex, symbiotic relationship with these organisms.
So it's not just about fighting off the bad ones, it's about recognizing and actively supporting the good ones.
Precisely. The source details some of the fundamental, vital roles these beneficial microbes play in human health. They are absolutely essential for aiding digestion, helping us break down food and absorb nutrients.
Okay, digestion. That makes sense. What else?
They assist in removing poisons and detoxifying certain compounds. They produce essential vitamins that our bodies actually can't make on their own.
Really? Like which ones?
Things like vitamin K, some B vitamins. And the source even goes so far as to cautiously suggest they may play a role in helping to reduce obesity.
Wow, okay. A potential link between gut bacteria and metabolism.
Exactly, indicating that potential link. These positive, often overlooked functions are absolutely foundational to our well-being.
And yet, paradoxically, modern human activities seem to be inadvertently harming these vital microbial communities that are so crucial to us.
That's another significant concern the source raises.
Yeah.
Our modern lifestyles, well, they have unintended consequences. The overuse and misuse of antibiotics, for instance.
Yeah, wipes out everything.
It can decimate beneficial bacteria along with the harmful ones. Modern, highly processed diets, sedentary lifestyles, even our obsession with extreme hygiene practices.
Eating too clean.
Potentially, yes. They can negatively impact the diversity and health of these delicate and vital microbial ecosystems within us. It really raises the question of whether our attempts to be clean are disrupting a fundamental partnership.
It sounds like we're potentially undermining our own health in complex ways we're only just beginning to understand.
That's certainly a key implication. But the source also looks forward, exploring the incredibly exciting possibilities that arise from understanding and intentionally manipulating microbes for human benefit.
Like a new kind of medicine or engineering? Using microbes for us.
Exactly. It provides a very specific, compelling example. Researchers are now loading specific bacteria into mosquitoes.
Into mosquitoes. Why?
Well, the presence of these bacteria in the mosquito actually blocks its ability to transmit the dengue fever virus.
No way. Dengue affects millions.
It affects a staggering 400 million people globally every year. So using bacteria within one organism to prevent the spread of disease to another, that's a brilliant piece of bioengineering.
It really is. A powerful demonstration of how we can harness the microbial world.
And based on the sources mentioned, you can speculate about future applications that sound like science fiction, but they're rooted in this research.
Go on.
Imagine incorporating useful infection-fighting microbes directly into building materials themselves.
Like into the walls.
Exactly. For example, in a neonatal hospital ward. Instead of relying solely on sterilization, the environment itself could actively fight off harmful pathogens, giving vulnerable newborns an extra layer of protection right from the start.
That completely flips the script on how we think about cleanliness and health environments. Instead of a sterile battlefield, it's a curated ecosystem.
It truly does. This deep dive into microbes completely changes your perception. You go from simply viewing bacteria as germs to recognizing them as essential, complex partners in our health
And potential tools.
and potentially powerful tools for tackling major global health issues, from infectious diseases to metabolic disorders. It's about understanding the unseen forces that profoundly impact your daily life in ways you likely never considered before.
Okay, so from the hidden world of microbes, shaping life and health at a microscopic level, and the adaptive biology of polar bears, we've been exploring different kinds of architecture, in a way.
Biological architecture, yeah.
Now let's make a huge leap in scale and time and turn our attention to the large-scale architects of the ancient world.
And some of their most impressive and perhaps underappreciated engineering feats. Roman tunnels and ships.
A dramatic transition, definitely, but one that highlights the persistent human drive to overcome environmental challenges and, connect the world, whether at a microscopic level or through monumental construction.
We often associate Romans with their vast network of roads and their iconic aqueducts, and rightly so. But as the source material points out, their tunnel engineering was equally remarkable.
And maybe it doesn't get the same level of recognition.
Perhaps not.
Tunnels make perfect sense for building empires, though, right? You can't just go around every mountain or under every river. You need to go through them sometimes.
Exactly. The source outlines the incredibly practical purposes behind Roman tunnels. It shows their very pragmatic approach to solving real-world problems necessary for their empire.
Like what? What were the main reasons?
They built tunnels to create roads through formidable obstacles like hills and mountains, to extract valuable minerals by following veins deep underground.
Mining tunnels.
Mining tunnels, yes, to supply water via aqueducts where above-ground channels were impassable, and even for strategic purposes, like protecting harbor mouths from silting up or from attack.
Okay, these were essential pieces of infrastructure. Given the lack of modern machinery, how on earth did they actually build these long, deep tunnels?
Well, the source details several quite sophisticated methods they employed. One key technique they used, interestingly, wasn't invented by the Romans, but learned from the Persians.
Oh, which one was that?
The Kanat method.
So they were good at adopting and scaling existing technologies too. How did the Kanat method work specifically for tunnels?
It involved directing water to a canal to serve as a guide, and then digging a series of vertical shafts down to the intended tunnel level.
Vertical shafts. How far apart?
These shafts were dug at intervals, typically between 30 to 60 meters apart along the planned tunnel path.
Okay.
They served a dual crucial purpose. They were used to haul out the vast amounts of excavated earth from underground.
Right, like a bucket brigade from hell.
Sort of, and they provided much-needed ventilation for the workers toiling below.
Vertical shafts every 30 to 60 meters. That must have been an immense amount of work just to access the tunnel level, let alone dig the tunnel itself.
It was a monumental undertaking in itself. The source highlights that the tools and techniques used within these shafts and the tunnel were, well, simple by today's standards, but incredibly effective.
Like what?
They would carve handholds and footholds directly into the sides of the shafts to allow workers to climb in and out. The shaft openings were often covered with wooden or stone lids, for safety and to control airflow.
Smart. And how do they maintain accuracy? Ensuring the shafts were vertical and the tunnel had the right slope and direction underground. That sounds tricky.
They relied heavily on the plumb line, a surprisingly simple but fundamental tool.
Just a weight on a string.
Basically, yes. They would hang a plumb line from a rod placed across the top of each shaft and make sure the weight hung precisely in the center, confirming the shaft was vertical.
Okay.
Plumb lines were also essential for accurately measuring the depth of the shafts and, critically for water tunnels, for determining and maintaining the required downward slope to ensure water flow.
That level of precision with such basic equipment is truly remarkable.
It is astounding for the time. Can you give us a sense of the scale of one of these Kanat projects?
Yeah, the source provides the incredible example of the Claudius Tunnel. Built starting in 41 CE,
Okay.
its aim was to drain the vast Fucine Lake in central Italy. This wasn't just a tunnel, it was an epic engineering project.
How long was it?
It measured a staggering 5.6 kilometers long, with some of the vertical shafts reaching depths of up to 122 meters. That's taller than many modern skyscrapers.
Unbelievable depth. How long did it take? How many people?
It took 11 years to complete and involved an estimated 30,000 workers.
30,000 people
Well,
for over a decade on one tunnel project. Mind-boggling.
It gives you a sense of the sheer human labor and organizational capacity required for these projects.
Absolutely. You mentioned a second method, too, the counter-excavation method.
Yes, this method appeared earlier, actually dating back to the 6th century BCE,
Okay.
and it was particularly necessary when the cannot method wasn't practical, primarily for cutting through high mountains, where digging numerous deep vertical shafts was just too difficult or impossible.
So how did counter-excavation work if you weren't digging shafts from the top down?
It required a different kind of genius, really. The tunnel was excavated simultaneously from both ends of the mountain.
Digging towards the middle. Exactly. With teams digging towards each other. This was significantly more intellectually demanding than the Kanat method because it required a much greater level of planning and sophisticated knowledge of surveying, mathematics, and geometry.
Because they had to meet correctly in the middle of the mountain,
Yeah.
under tons of rock.
Precisely. It wasn't just about brute force. It was a complex calculation and coordination problem requiring advanced technical skill for the time.
The source points out that constant surveying checks and adjustments were necessary throughout the process,
Makes sense.
both to correct for any geological problems encountered underground and to ensure that the two ends stayed on track and would actually connect. It was a technically challenging endeavor that really pushed the limits of their engineering knowledge.
The source also gives some concrete examples of different types of Roman tunnels, which helps ground this in reality.
Yes, like their road tunnels. A fantastic example is the Furlow Pass Tunnel in Italy, built between 69 and 79 CE.
Okay.
It's 37 meters long and 6 meters high. And the truly astonishing fact, highlighted in the source, the one I mentioned earlier.
Yes, a modern road still uses this tunnel today.
That is just mind-blowing. A piece of infrastructure built nearly 2,000 years ago is still part of the active transportation network today. That speaks volumes about the quality and durability of Roman engineering.
It's an incredible testament to their skill and the materials they used.
Mm.
The source also mentions mining tunnels, with traces found at the Dolocothi mines in Wales.
Built to extract gold.
Right. And the Chevlik tunnel, built to protect the harbor mouth of Seleucia Pieria, shows they applied tunneling to port infrastructure as well.
Mining tunnels. That must have been dark, dangerous, and just claustrophobic work. What were some of the practical challenges they faced while digging?
Well, the source notes that the speed of progress varied dramatically depending on the type of rock they were excavating through. Not surprising.
Harder rock, slower progress.
Much slower. In particularly hard rock, they had to employ a technique called fire quenching.
Fire quenching. What's that?
This involved heating the rock face with fire for extended periods and then rapidly cooling it by dousing it with cold water.
Thermal shock.
Exactly. This temperature shock would cause the rock to crack and splinter, making it possible to break it away with tools.
Fire and water underground to break rock. That sounds intensely difficult and incredibly slow.
It was extremely arduous. The source illustrates the slow pace with an example from a Roman tunnel in Bologna. The rate of advance through solid rock was sometimes only about 30 centimeters per day.
30 centimeters.
A foot a day, roughly. This meant that these tunnels could take years, sometimes even decades, to complete. Imagine dedicating your working life to advancing a tunnel by just a few inches a day.
It gives you a profound appreciation for the persistence and sheer labor involved. The source also mentioned something about recognition for the engineers or architects.
Yes, that was a nice humanizing detail. Patrons would commission these huge tunnel projects, right?
Sure.
And sometimes the name of the architect or engineer responsible was carved onto the tunnel alongside the patron's name.
Oh, cool. Like giving credit where credit's due.
It shows that this highly specialized skill was valued and recognized in Roman society.
This whole section on Roman tunnels really highlights the incredible ingenuity, the problem solving, and the sheer persistence of ancient engineers using, well, seemingly simple tools.
It reveals how foundational infrastructure, built with immense effort, was designed to last for centuries and continues to impact modern life today. Really makes you think about the hidden history and engineering marvels beneath the ground you walk on.
It gives you a new layer of appreciation for the built world around us, definitely. Now, from tunnels beneath the land, essential for connecting the empire internally.
Let's move to the ships that allowed the Romans to dominate the seas and project their power and trade across the Mediterranean.
Right. The Romans didn't just build on land. Their mastery of the sea was absolutely critical to their empire's existence. It led them to proudly call the Mediterranean Mare Nostrum, meaning our sea.
A bold claim. And this control was entirely dependent on their shipbuilding expertise.
Exactly. The source identifies two main types of Roman ships, and crucially, emphasizes that their designs were specifically tailored to their very different, distinct purposes:
Which were?
warships and merchant ships.
Okay, military function versus trade and transport makes sense. What were the key design differences driven by these specific needs?
Well, warships were designed for military purposes: speed, maneuverability, and the ability to operate effectively close to the coast for landings or, naval battles near land.
Okay, so fast and agile near shore.
The source described their key design features. They were lightweight, built for speed, with a long and narrow hull. And here's a critical difference. They carried no ballast or excess load.
No ballast. That seems counterintuitive. It goes against the common understanding of needing weight for stability at sea.
It was a deliberate design choice, though, serving their specific purpose. This lack of ballast made them lighter and faster,
Right.
and it allowed them to sail and operate in shallower waters closer to the shore than heavily laden merchant ships could.
Ah, okay. Tactical advantage.
And the source notes an interesting consequence of this design. If they were severely damaged in battle, they often wouldn't sink completely.
Really?
They'd lie crippled on the surface.
Huh. So perhaps increasing the chances of survival for the crew, or maybe even salvaging the ship later?
Possibly.
Got it.
Their primary weapon, as highlighted in the source, was typically a heavy bronze battering ram mounted on the bow,
The classic ram.
designed to pierce the hulls of enemy vessels or break their oars during engagements. For propulsion, warships used a combination of both wind power from sails and dehuman power from oarsmen.
Got it. Sails and oars.
The source points out that this combination made them very fast and agile for naval combat.
And the source mentions the trireme as a prime example.
Yes, the trireme is that classic image of a Roman warship, known specifically for having its rowers arranged on 3 different levels, one above the other.
To maximize the oar power.
Exactly. The source notes that over time, as the Roman Navy grew and evolved into the dominant force in the Mediterranean, larger ships with even more rowers eventually superseded the trireme.
Okay, so speed, agility, and coastal operation for warships. How did merchant ships differ? They must have been built for capacity, right?
Merchant ships had a fundamentally different objective: transporting large quantities of cargo over long distances as efficiently and economically as possible. Their design prioritized capacity, stability, and seaworthiness for open sea voyages.
So they must have been much larger and wider, I assume.
Yes, the source confirms they had a wider hull compared to warships. They were built with double planking for strength and had a solid interior structure for added stability.
Okay.
Crucially, their V-shaped hull had a deep draft, meaning it sat much lower and deeper in the water.
Which, unlike warships, meant they couldn't sail too close to the coast.
Exactly, a key operational difference. Steering was typically managed by 2 large side rudders positioned off the stern,
Side rudders, okay.
which were controlled by a tiller bar connected to a system of cables. For sails, they usually had 1 to 3 masts carrying large square sails, often supplemented by a small triangular sail at the bow for maneuverability.
Did merchant ships also use oarsmen like the warships did?
Yes, the source mentions they used oarsmen as well, particularly for maneuvering in harbors, or maybe against light winds.
But wind was primary for long trips.
Wind was the primary power source for the long-distance voyages required for trade. And here's a fascinating detail from the source about the oarsmen, common to both types of ships.
Oh.
Coordinating the hundreds of rowers on these large vessels was, understandably, a complex task. They actually used music,
Music.
often played on an instrument like a flute, to help the oarsmen keep time and maintain a synchronized rhythm.
Music for the rowers. That is a truly wonderful human detail. It really brings the ancient world to life, doesn't it?
It really does. You can almost picture these massive ships, propelled by hundreds of synchronized oars, with the rhythm set by music echoing across the water.
It humanizes the immense physical effort involved and shows their practical approach to managing large crews. The source then directly connects the importance of these ships to the Roman economy.
Right. The merchant ships were the lifeblood of their trade network, transporting vast amounts of vital cargo.
What kind of goods were they moving across the sea? Anything specific mentioned?
Everything needed to feed and build the empire, basically. Raw materials were crucial, like heavy iron bars, copper, marble, and granite, transported from quarries and mines across the Mediterranean.
Okay, building materials. What else?
Agricultural products were also essential, especially grain, particularly from the fertile Nile Valley in Egypt, which was a major breadbasket for Rome.
Ah, grain from Egypt. Classic.
And the source provides important context here. Rome itself was a massive city, around 1 million inhabitants during the height of the empire,
1 million people back then. Huge.
requiring a constant enormous supply of goods from all corners of the known world just to sustain itself.
So these merchant ships weren't just for luxury trade or anything. They were absolutely fundamental for feeding the population and providing the materials needed for their monumental building projects.
They were absolutely vital for sustaining that vast urban population and enabling the economic engine of the empire. This section vividly illustrates how specific technological designs, those subtle but critical differences between war and merchant ships, were fundamental,
Not just for military dominance and controlling the seas.
but also for the economic prosperity and even the sheer survival of the Roman Empire.
Yeah.
And yeah, the detail about music for the rowers is a truly memorable touch.
It is. So, okay, we've gone from the microscopic architecture of microbes and the adaptive biology of polar bears through the enduring architectural and naval ingenuity of the Romans, showing how design serves purpose across different scales and eras.
Now let's fast forward, way forward to the modern era, and discuss how current technology is profoundly shaping not just our infrastructure or our economy, but our very minds and the nature of work in the 21st century.
A critically relevant shift indeed. Let's start with something you experience every single day: how we read. Just glance around anyway people are waiting or traveling airports, trains, coffee shops, everyone is reading on screens, right?
Yeah, tablets, smartphones, news feeds constantly updating. Everywhere.
The source material presents a powerful argument. This isn't just a change in the format of text, it's fundamentally changing how our brains read.
That's a really significant claim.
Yeah.
How can simply changing the medium we read on actually change our brains? Seems like a big leap.
Well, the source points to findings from neurosciences, indicating that the neuronal circuit in our brains that underlies reading is not static.
Okay.
It's subtly and, importantly, rapidly changing in response to our reading environment. And it's crucial context to remember that this reading circuit isn't something we're genetically pre-programmed with, like, say, the basic ability for vision.
Right, reading is learned, invented, really.
It's a cultural invention, something that had to be acquired and developed over millennia of human history. It evolved from simple decoding tasks, counting goats on clay tablets over 6,000 years ago, to the highly complex reading brain that allows us to engage with sophisticated text today.
So it's a learned circuit, and learned circuits can adapt. Okay, what does this fully developed reading brain typically enable us to do when we read deeply? What are we talking about?
The source lists several crucial intellectual and affective processes that this highly developed circuit supports when engaged in what is sometimes called deep reading.
Okay, deep reading skills like...
These are high-value cognitive skills, fundamental to understanding the world and engaging with complex ideas. Things like internalized knowledge, the ability to perform analogical reasoning,
seeing connections,
drawing inferences beyond the literal text, taking on different perspectives, developing empathy through understanding characters or arguments, engaging in critical analysis,
thinking for yourself about it.
and ultimately the generation of new insight, original thought.
Those are foundational skills, not just for academic study, but for navigating a complex world, understanding different viewpoints, and creative thinking in general.
Exactly. And the concern, based on research emerging from labs around the world, according to the source, is that these essential deep reading processes may be under threat.
Because of digital reading.
As our dominant mode of reading shifts increasingly towards digital media, yes. That's the potential downside researchers are cautioning us about.
So the way we consume information digitally might be making us less capable of these deeper forms of comprehension, analysis, and empathy. That's worrying.
That is the potential downside being explored. The source frames this issue not as a simple binary print versus digital debate. It's more nuanced.
Okay.
It draws on the idea attributed to the MIT scholar Sherry Turkle that the fundamental societal error isn't in innovating with technology that's often positive and necessary.
Right, innovation is good.
But the error is in ignoring what we disrupt or diminish while innovating. We need to be eyes wide open about the trade-offs involved.
So we gain incredible access and speed with digital reading, but potentially at the cost of some deeper cognitive processing. Is that the idea?
That's the hypothesis being explored, yes. The source explained how this change might be happening. The reading circuit is incredibly plastic. It adapts to its environment and the demands of the medium being used.
Okay.
Since the dominant digital medium favors processes that are fast, encourages multitasking, checking notifications, clicking links,
Yeah, constant distractions built in.
and is designed for handling vast volumes of quickly accessible information, the writing circuit adapts accordingly. It starts prioritizing speed and breadth over depth.
And the consequence of prioritizing speed and breadth, what happens then?
Well, as noted by UCLA psychologist Patricia Greenfield, who's referenced in the source, the result is that less attention and time are allocated by the brain to the slower, more time-demanding processes.
The ones needed for deep reading.
Exactly. The analysis, the reflection, the synthesis that lead to internalized knowledge and genuine insight.
So our brains are becoming highly optimized for skimming, scanning, and consuming large volumes rapidly, which is useful, no doubt, but potentially less optimized for deep analytical work.
That's the concern, yes. That's the potential shift. However, the story presented in the source isn't one of, inevitable decline or doom.
Oh, good.
It offers a note of hope, emphasizing that the future is not yet written. We possess both the scientific tools, like neuroimaging,
Right.
and the technological capability to identify and understand these changes as they are happening, and potentially course-correct before these shifts become permanently entrenched in the population.
So we have the agency to understand what's happening and make conscious choices
Yeah.
about how we design digital interfaces, maybe, or educate future generations to ensure these deep reading skills are preserved.
Exactly. The source's powerful point is that we need to understand clearly what skills, what cognitive abilities, what human capacities we risk losing or diminishing alongside the extraordinary new capabilities and access that the digital age offers. It's a call for critical awareness, basically, combining excitement about technological potential with caution about unintended consequences, and a reminder that we have the power to shape this evolution.
This is incredibly relevant. It directly impacts your own cognitive life, how you learn, how you engage with information every single day in the digital age. It makes you think critically about your own reading habits, for sure.
It absolutely prompts that crucial self-reflection. Now, having explored how technology is subtly changing our reading minds, let's shift gears again.
Okay.
Let's look at how the increasing prevalence of algorithms and AI is changing the very nature of our jobs and the workplace itself.
Yeah, this is a huge ongoing conversation everywhere. The source sets the stage by pointing out that AI is already capable of predicting outcomes in complex practical fields like policing and medicine.
Right. And researchers are even pushing its capabilities further, exploring the idea of giving AI imagination.
Imagination, wow. Okay. It's clear that algorithms are stepping into roles previously assumed to require human cognitive ability.
And the source focuses on research like that of Stella Paccitti, who has been exploring what she terms the algorithmication of routine cognitive tasks within organizations.
Algorithmication. Catchy.
It is. The process by which AI systems take over tasks that previously required human thought and judgment, even if those tasks were relatively standardized.
What are the primary reasons or driving forces behind companies adopting algorithms to take over these tasks? Why are they doing it?
The source mentions several organizational drivers. Companies are motivated by the desire to make decisions based on what they see as perfect information or, data-driven objectivity.
Okay, less human bias, maybe.
That's the idea. Also, to reduce operational costs by automating processes and to enhance overall productivity and efficiency. The business case for automation of routine tasks is often pretty compelling from a traditional economic standpoint.
But if AI takes over these routine tasks, what are the potential consequences, particularly for human workers, beyond just losing the task itself?
That's where Paccitti raises significant concerns. If AI handles the routine cognitive tasks that make up a significant part of many jobs, she questions how future experts in those fields will actually learn their profession.
The learning pipeline.
Exactly. She highlights the concept of legitimate peripheral participation. It's a traditional sociological idea.
Okay.
It describes how novices learn a trade or profession by observing and participating in the periphery of expert work, gradually moving towards the core tasks.
Learning by doing, by watching.
Right. But if the peripheral participation is now handled by algorithms, where do future experts gain that foundational, practical understanding? It necessitates finding entirely new ways to structure learning and development within the workplace.
That's a really profound point. If the entry-level, more routine cognitive work is automated, how do you acquire the on-the-job experience needed to become an expert later on?
It forces a rethinking of training pathways and skill acquisition in a future where AI is a constant colleague or maybe even a supervisor. Paci's research also delves into the issue of influence and control that algorithms exert.
No.
The source details her observation at a specific telecommunications company.
What did she observe happening there? What did the algorithm do?
She saw an algorithm that was directly dictating specific actions for account managers. It wasn't just providing suggestions, it was telling them precisely when to contact particular clients,
Okay.
identifying which specific marketing campaigns or offers to discuss with them. This is a clear example of AI directly influencing and to some extent controlling human work.
Work that was previously based on the account manager's experience, their relationship with the client, their personal judgment.
Exactly. So the algorithm isn't just doing a task, it's directing the workflow and even the specific decisions of the human worker.
Which brings us to another crucial point, the source material addresses, drawing from other sources. The human element of trust when interacting with AI systems.
Yeah, trust is huge. There is noted a widespread lack of confidence and a general reluctance among people to fully accept or rely on AI in many contexts.
Why is there this difficulty with trusting AI, even if its performance is technically good? We trust human experts usually.
Well, the source explains the reasons for this widespread distrust quite well. Trust in human beings is fundamentally based on our ability to understand their thought processes, their motivations.
We had a feel for them.
And having built up a history of experiencing their reliability over time, this history and understanding create a sense of psychological safety.
Okay.
AI, on the other hand, is often new and unfamiliar. Even if the underlying technology can be explained, the actual decision-making process of a complex algorithm can be opaque.
The black box.
A black box, exactly. Too intricate for most people to fully grasp or intuit. This lack of transparency and understanding can lead to anxiety, fear of the unknown, and a sense of losing control over outcomes.
If you don't understand the why behind an AI's decision, it's hard to feel comfortable relying on it, even if the outcome is correct this time. You don't know if it'll be right next time.
Precisely. It impacts our sense of control and predictability. The source does note, though, that researchers are actively working to address this by making AI systems more trustworthy and, crucially, more transparent, aiming for people to understand not just what decision the AI made, but how it arrived at that decision. Explainable AI, they call it sometimes.
So it's a recognized challenge,
Mm-hmm.
and the tech community is aware it needs to build trust, not just capability.
Okay.
But zooming out to the bigger picture of AI's impact on jobs and the economy.
Mm-hmm.
The source also presents economic perspectives that offer a counterpoint to the more fearful, job-killing narratives often discussed.
Yes, it introduces the views of economists who challenge the more, apocalyptic visions of a future with mass unemployment due to automation. Hamish Lowe, for instance.
Okay, what does he argue?
He argues that while significant transitions in the labor market are undoubtedly ahead, AI and automation's primary effect is actually to increase productivity.
And increased productivity historically leads to more jobs, not fewer. Is that the idea?
That's his core argument, yeah. Grounded in historical economic trends. He uses a simple example. If technology increases productivity to the point where the work previously done by 100 people can now be done by 50,
Right.
that doesn't mean the other 50 are permanently unemployed. Historically, increased productivity fuels economic growth and creates wealth,
Right.
which in turn generates demand for new goods and services, leading to the creation of more jobs overall, potentially turning those original 100 job opportunities into 150 across the economy as it expands.
That's a much more optimistic and, well, historically informed perspective than simply focusing on displacement.
It is. And Ewan McGaughey offers another perspective, largely agreeing that fears of mass job losses driven by technology itself are misguided.
So what does he think causes unemployment if not tech?
He argues that unemployment isn't primarily caused by new technology, but by laws and policies that restrict the supply of capital into the job market or, frankly, fail to manage transitions effectively.
So in his view, the problem isn't the AI, it's how we regulate the economy and support workers through the change.
That's his position, yes. He states that while history shows technological change can certainly cause specific job redundancies in certain sectors, these transitions can and should be managed through deliberate social policies.
Like what kind of policies?
Things like robust retraining programs, active redeployment assistance, strengthening social safety nets. He offers what the source describes as a call to arms for leaders,
A call to arms. Strong words.
urging governments, organizations, financial institutions to view the AI shift not just as a challenge, but as a significant opportunity to proactively improve public policy and force strong job security measures.
Okay.
And even, as he puts it, reprogram the law itself to ensure a fairer distribution of the benefits from increased productivity,
Yeah.
potentially leading to a future with a better balance of work and leisure for everyone.
These economic perspectives are really important because they shift the focus away from just fearing the technology's capability
Right.
to emphasizing the societal and political choices we need to make in response to it. It puts the agency back in human hands, focusing on policy and adaptation, not just tech determinism.
Exactly. This entire section on the evolving human and the rise of algorithms is profoundly relevant to you, the listener.
Okay.
It touches on your own cognitive life, how you might learn new skills throughout your career.
And the broader societal and economic transformations you are living through and will continue to experience.
Absolutely. It offers a much more nuanced perspective than simple technological determinism, highlighting the interplay of learning, trust, policy, and human agency in shaping the future.
It certainly gives you a lot to think about, both on a personal level and in terms of the societal choices we face.
It does indeed.
Well, we've covered a remarkable amount of ground in this deep dive, haven't we? Spanning incredibly diverse fields.
We really have. We've journeyed from the surprising genetic adaptations of polar bears that might hold secrets for human health,
Yeah.
and plunged into the essential, often overlooked hidden world of microbes that are our partners in health.
Then we time traveled back to appreciate the enduring legacy of Roman tunnels, some still in use today, amazingly.
And the sophisticated, purpose-driven design behind their powerful ships that enabled an empire.
And finally, we landed squarely in the present, exploring the contemporary shifts in how our brains engage with information in the digital age.
And the complex, multifaceted future of work as algorithms become increasingly prevalent. It's been quite a ride.
It truly highlights how deep dives into varied sources, even those seemingly disconnected at first glance, can reveal fascinating connections and crucial insights.
Things that simply staying on the surface of any single topic would miss. We saw adaptation across species and time, engineering ingenuity from plumb lines to programmed systems.
And the constant interplay between humans and their environment, whether that environment is biological or technological.
Being well-informed really does come from exploring these diverse corners of knowledge and understanding how they might be linked, even in unexpected ways.
Agreed. So as we wrap up this deep dive, here's a thought for you to ponder, building on these themes of technological change, human adaptation, and the evolving nature of skills and work we've explored.
Okay, leave us with something to chew on.
As technology continues to reshape both our fundamental cognitive abilities, like how we read and learn, and the very definition of what constitutes valuable work, what core human skills, qualities, and values become most essential.
Most essential for you to cultivate within yourself, perhaps.
Exactly. And for us to nurture in society, to navigate and thrive in a fulfilling future, what really matters most.
A big question. Something to think about until our next deep dive.
Thanks for joining us.
Thank you.